Welcome, my dear students, to take information under first year part, that is hydrocarbons. Somehow we discussed in live classes, that is up to physical properties of alkanes by all the lecturers. Next continuation in case of hydrocarbons, particularly alkanes, we are going to take the information under chemical properties of alkanes. As what is observed here, alkanes are generally inert. Why they are inert? Because carbon-carbon bond and carbon-hydrogen bond are less polar. Carbon-carbon bond and carbon-hydrogen bond are less polar. So due to less polarity, these are inert towards acids, bases, acids like HCl, and bases like NaOH, oxidizing agents and reducing agents. So previously we discussed this one as paraffins. These are less reactive towards chemical properties. That's why these are called less affins. As what is taken, param and affins. These are the two words named as paraffins. Yes. What type of reactions these alkanes undergo? Alkanes undergo certain reactions like substitution reactions. What is substitution reaction? As in a compound, an atom or group of atoms removed and introduced by another one is replaced, like we are observing in some games like kabaddi and etc. In the middle of the game, with the permission of the umpire, and we have to introduce a new player in the place of one already existing player. Yes, that is substitution reaction. In a reaction, an atom or group of atoms replaced by another atom or group of atoms. Next one, combustion. Heating in the presence of air is called combustion, and controlled oxidation, here we are adding hydrogen. Yes. Next one is isomerization, is another reaction, will be explained very soon. Next, pyrolysis is very important, that is, and the last one is reaction with steam. These are some reactions we are going to discuss very soon. Now take down what is substitution reaction. Already explained, an atom or group of atoms are replaced by another atom or group of atoms during a reaction is called substitution reaction, like a coco game, kabaddi, football, volleyball. These are all games, and also cricket. Cricket is not for bowling and batting, only for fielding purpose. A new player will be introduced in the middle of the game when a player is injured or not feeling well. Yes, one or more hydrogen atoms of alkanes can be replaced by halogen. That reaction is called halogenation. What are halogens? Fluorine, FCl, chlorine, Br, bromine, I introduced in the place of one or more hydrogens. That reaction is called halogenation. Next, nitro group is introduced. That reaction is known as nitration. What is a nitro group? NO2 is introduced by replacing one hydrogen from the alkanes. Next, sulfonic acid group is introduced. That is SO3H. That reaction is known as sulfonation. That is. Next, what is a halogenation? Let us take, as we are introducing a halogen atom into the substrate like alkane or some other compounds, that is always known as halogenation, and it is performed at higher temperatures. We are heating the mixture of halogen and alkane at higher temperatures like 573 to 773 Kelvin temperature. Or if it is not provided, we have to use a diffuser light. What is a diffuser light? Yes, the diffuser light property is which is very soft and penetrated more when compared to normal light and scattered to all directions, is very property, special property by a light, that is sunlight, diffused sunlight. How do we obtain this one? Yes, the light ray fallen through the object, then what is observed? The resulting light is uniformly distributed with softness and penetrated more into the substance, means reaction is very uniform, and scattering to all directions is also the property. If this is not provided sunlight, you can also use ultraviolet rays. So how is this performed? This is performed by A free radical substitution reaction. What is a free radical? Yes, the free radical is formed by the homolytic cleavage of a covalent bond. Yes, take a covalent bond here. Yes, observe here, covalent bond A, B covalent bond, and 2 electrons of covalent bond is equally cleaved in this manner. Equally cleaved in this manner by fishhook symbol. This is shown as like this, and it is a homolytic cleavage, equally cleaved, and you will get species with one shared pair electron. This is called free radical, and you learned in the previous lesson. Continue the discussions under halogenation of alkanes. The one is chlorination of methane in the presence of sunlight. For what purpose? To initiate the reaction. Give monochloromethane first. So CH4, one hydrogen is substituted by one chlorine, chloromethane, and 2 hydrogens substituted by 2 chlorines, dichloromethane. Third chlorine is introduced by removing third hydrogen. Fourth chlorine is resulted, and finally you are getting tetrachloromethane. See the same information, CH4 plus Cl2 in the presence of sunlight. Sunlight is shown by CH nu. Yes, this is H nu, and this is CH3Cl, that is chloromethane, and also known as methyl chloride, common name, and the side product is HCl. This CH3Cl is not possible to stop at this stage. Further reacted with chlorine. If we take a more amount of chlorine, H nu, that is sunlight, then second step is happening. So CH4 becomes CH3, CH3 becomes CH2. So number of chlorine atoms increasing and hydrogen atoms are decreasing. Here CH2Cl2, it is named as dichloromethane in IUPAC system, and HCl. It is also known as methylene chloride. This CH2 group is known as methylene group, that is methylene group. And next one, CH2Cl 2 plus Cl2 gives CHCl3, that is trichloromethane, also known as chloroform. This is common name. As be familiar with both the names, IUPAC name as well as common name. Common names are most frequently used in our discussions rather than IUPAC name. And next one is this CHCl3, that is chloroform, finally reacted with chlorine, means the reaction is coming to completion, CCl4. So this entire reaction cannot be stopped at any one of the middle stages. Finally we got CH4 is started with the excess Cl2. You will get CCl4 as final product, that is fully halogenated alkane is produced, that is carbon tetrachloride, the final product. Yes, observe in the halogenation of alkanes. Right, in the halogenation of alkanes, what happened? Order of reactivity of halogens F2. F2 is very reactive, and explosion is taking place with F2. What is the type of reaction? Explosion takes place, very reactive one, and Cl2 moderate, Br2 moderate. I2, with I2 the reaction is reversible. It is reversible, and that's why the reactivity from F2 to I2 decreasing is one point you have to prepare. Next, order of reactivity of hydrogens in alkanes. Alkane have different hydrogens. Of course, methane has R4. All 4 hydrogens are identical. There is no speciality. So they are very clear. And the reactivity of different hydrogens is tertiary hydrogen, where to tertiary hydrogen attached to tertiary carbon, that is tertiary hydrogen, secondary hydrogen, primary hydrogen. In this way, the competition is happening and they are removed in this order. When compared to primary and secondary, tertiary is preferentially substituted in the reaction. When compared to primary, secondary is preferentially substituted with halogen. So this is one reactivity. For competitive point of view, what you have to observe? Yes, observe this one, chlorination. Yes, tertiary hydrogen is 5 times faster when compared to primary hydrogen, and 3.8 times faster than primary hydrogen. So 3 different hydrogens present in the compound. Suppose if you take a CH3, CH, CH3, CH2, CH3 taken, this is primary hydrogen, primary hydrogen, primary hydrogen, 9 primary hydrogens are present, and it is a secondary hydrogen, this is tertiary hydrogen. So tertiary hydrogen is more reactive than secondary hydrogen than primary hydrogens. So that is the information here provided. for competitive point of view. So chlorination in this way. Bromination is very reactive when compared to chlorination. Yes, tertiary hydrogen is 1600 times faster in the reaction when compared to primary hydrogen, and 82 times greater reactivity over secondary hydrogen is greater reactivity over primary hydrogen. This you have to take. Iodine is, with iodine the reaction is reversible. With F2 the reaction is explosion. So explosion reactions we are not allowing. Reversible reactions we are not allowing. The moderate one is Cl2 Br2. So Br2 in introducing of bromine is very selective. So bromination is selective, like that we will discuss later with some examples for competitive point of view. Here observe only for competitive point of view. I have CH3, CH2, CH2, CH3. Its name is butane, N-butane. Its name is butane. With chlorine, how many chlorines equivalent? Equivalent is obtained by weight of the substance divided by gram equivalent weight, like moles. Moles are obtained by dividing weight with gram molecular weight. So these concepts are already familiar by you. So one equivalent is more meaningful than, and sometimes equivalent is equal to moles, but all cases it is not true. And one equivalent of Cl2 means 1 mole of Cl2 nearly added in the presence of sunlight. What happened? Yes, here one CH3 is removed, primary hydrogen, secondary hydrogen, 3 plus 3, 6 primary hydrogens, and what are present? 2 plus 2, 4 secondary hydrogens are present. Clear? So which is more reactive? Number of monochloro substitutions. Yes, how do you write this one? Very simple. By substituting first hydrogen on primary carbon, that is 1, and secondary hydrogen is second one. So 1 chlorobutane, 2 chlorobutane. So number of monochloro derivatives are 2. Yes. Which is the major product? That will be calculated based on the previous one, will be taken very soon. As towards explanation, this is treated with chlorine. What is happened? These there is. So number of primary hydrogens are 6. The reactivity is into reactivity 1 time 6. Next, number of secondary hydrogens are, as this is secondary, this is secondary, these two are secondary hydrogens. And what is observed here? 4 into the reactivity of chlorine is 3.8, that is 3.8. 4 3s are 4 8s are 32, 4 3s are 12, 12 plus 3, 15.2. Yes, the percentage of 1 chlorobutane is as how many? 6 chlorine atoms. Number of primary hydrogens reactivity divided by total reactivity into 100. Yes, what is total reactivity? Come back. Total reactivity is equal to 6 plus 25.2 no, what is this one? 4 8s are 32, 4 3s are 12, 12 plus 3, 15. This is 15.2. So that is 6 plus 15.2, that is 21.2 is the total reactivity. Therefore, come to primary chlorines, 6 by reactivity of 6 primary hydrogen, 6 by 21.2 into 100. Next, percentage of 2-chlorobutane. Butane is equal to how many secondary chlorines? 4. Their reactivity is 15.2 divided by 21.5 into 100. So which is major product? Either secondary chlorine 2-chlorobutane or 1-chlorobutane. Yes, based on this calculation, based on the calculation, what is your opinion? Yes, coming back to the previous one, we can easily continue. Yes, observe the major product is yes 2-chlorobutane is the major product. Next, observe another example. This is yes, you are getting confusion. I will give you later.